Hello, this is Mr. Huff. Let's talk about these formulas. This has to do with lapse rate. One of the things I want to point out, these formulas are only consistent in this zone right here. We're only talking about the troposphere, and we're going from 0 to 36,000 feet. It's about 11 kilometers there. That's all we're interested in. So, and you can I'm not going to try to discuss this graph any, so we're just going to look at just this zone here. So our numbers will be between 1 and 11,000 meters. Okay, so with this in mind, here's our first one. There's a lot of letters here, but you need to recognize that the only variables are the T and the H, just the T and the H. The rest of this is for units so that you can cancel out your height, your altitude, and be left with degrees Celsius. This formula is linked to the pressure formula because it's the only variable in here. Everything else is showing how the units cancel out so that you're left with kilopascals. And notice this, when you see a formula like this that has these really specific constants in here, you have a conversion here, but this information here is based on an empirical experiment that generated this formula that shows the relationship between temperature and pressure using standard temperature and pressure. If you've had chemistry, you can think about the gas laws that you learned about and the term STP, which is standard temperature and standard pressure. So that's what we're comparing everything to, not the actual temperature and actual pressure. This is to show the lapse rate, how the temperature changes as you gain altitude, and as that temperature changes, what happens to your pressure as you gain altitude. So these are all connected. Temperature relies on altitude and pressure relies on temperature at that altitude. So hopefully that makes sense. All right, let's take a look at an example. So this problem might say something like, if your aircraft is flying at 7,000 meters, what is the temperature? So we only have one variable there, or one value there that's given to us. So write down H equals 7,000 meters, and then our unknown is right here. Temperature is equal to some number of degrees in degrees Celsius. Our equation, and it's a little weird, I'm using a text editor here to show this, but this is our formula. It's the standard temperature minus this conversion factor of how many degrees Celsius per meter times the height. When we do our substitution, let's just boil that down to the numbers and get rid of the units in there so we can see what's going on with just the math. It is this number times the product of these two. So multiply these first and then subtract them from this. Okay, so when you do this calculation here, you get a negative 30.39, and that's for significant figures. Don't forget the sign on this. Most of these numbers are going to be like 25-ish degrees or less, because the higher up you go, the lower the temperature gets. All right, and so then another one would be, let's look at one that does pressure. So let's look at a pressure problem. This one, all you're going to get is a temperature, and we'll start with negative 30, similar to our last problem. Let's see what kind of a pressure we're talking about there. So negative 30 is our temperature, and we're going to try to find the pressure. The unit we're using is kilopascals, or kPa. So write these down, show your equation. Again, I'm using a text editor, so it looks a little weird, but it's the standard pressure times the conversion factor to turn degrees Celsius into degrees Kelvin, and that's what this nonsense is all about. So you have your temperature here, divided by 288.08 Kelvin, raised, okay, you're going to subtract these first, and then you're going to divide these by this number, and that's going to give you a single number here. You're going to raise this by 5.256. That's a power. So on your calculator, there's usually a little grave or an X to a box, and you'll put that in as the exponent. Okay, and then when you get that expression completed, then you multiply times 101.29. So if you to do this all at once in your calculator, do this. So we're going to put 101.29 times, open a parenthesis, open a second parenthesis, so you can do this calculation first, My advice is on your calculator, use parentheses only for separating. Use the multiply button when you mean multiply. Don't use parentheses to multiply because you will get confused. So we're going to find the sum of these first, and we're going to divide that number by 288.08, and then we're going to take that number, raise it to the 5.256 power, and then we're going to multiply that times our standard pressure. And when we do that, we get 41.5 kPa. Let's do a little sanity check here. So a sanity check, at 25 degrees Celsius, the pressure is going to be 121 kPa. So most of your answers are going to be less, and sometimes a lot less, than 121 kPa for pressure. So that is just a real quick walkthrough of how to do a temperature calculation based on altitude, and then a pressure calculation based on temperature. And all of this is connected by these two formulas that we just talked about right here. And this only works in this level of the atmosphere. As you go up, you can see the rules change for how lapse rate works. This green line represents lapse rate. All right, that's all I have for this video. Let me know if you have any questions.